Now, again, I really don't want to have to talk to people about not doing anything. So, let's go ahead and just go over these. So hopefully you guys will be good. Now, I'm going to tell you guys right now. I'm looking at the test. Okay. Okay, from the test. That one's not on it. This was asking dilations. There is no dilations on the test though. Dilation A is this one right here. So it's asking for which one, basically which one's a quarter. Which one's going to be a quarter? Quarter is the smallest out of all these, right? So that's going to be B, right? Okay, so it's just going to be B is going to go there, right? Which one is the largest? A, so that one's going to go there, and my last one goes there. So, I'm telling you, dilation scale factor is not on there.
Hold on. So,
Wait, dilation and scale factor?
okay, why'd you tell me this was right and it was wrong?
We don't matter.
I told you the right answers. I don't know what you wrote down, though.
Yeah, you said I.
No.
Yes,
I
you
told
did.
you what the right answers were.
Okay, bro.
All right, so don't worry about this. All right, let's take a look at this one right here. You shush. Lesson 2. This one right here, it's asking for, okay, image of an upright cone with base resting horizontal on your desk. So the base is on the desk, right? So the pointy point is pointing up. Okay, match each plane with the image of the cross section formed by intersecting plane with the cone. Horizontal is, think of the word horizon. Now, with your hands, everyone right now, because I know you're not playing with your phone, you're actually doing this. So, which way is the horizon? With your hands. For those people paying attention, everyone over there, yeah, take out earbuds. Which way is horizon?
That way.
Look at the horizon. What's it look like? Let me see the hands, all those people, right? Okay, good. So that is horizontal line. So when I had the cone resting on my desk and I chopped off the top of it, what shape did it make? I made a circle, right?
Yeah.
So this is my B, right? Oh wait, sorry. A, I'm sorry. I don't know what I'm doing. Okay. All right, A. That's going to be A. Vertical. All right, let's say we had someone in here that knew how to play basketball.
Me.
He said me.
Okay. Basketball. Is there a concept about vertical in basketball? What does that refer to?
How high you can jump?
Yeah.
How high? Which way is that?
We're up.
Up. So it'd be straight up and down, right? So a vertical line would be straight up and down. When I chopped, remember I actually did this. I karate chopped that cone. Remember?
Yeah.
I karate chopped that cone. And when I karate chopped that cone, what shape did I get when I karate chopped it not down the center?
That.
It's going to be what?
One.
One right here. This is going to be my parabola, right? Diagonal. With your hand. Show me a diagonal.
It's just C.
Okay. For those computer people, think of backslash or forward slash. That's your diagonal. So when I diagonaled that cone, I chopped it and I came up with this one here, right? Oh wait. Oh, here it is. Select all figures which have a cross section that are circles. Okay, do you think it's possible to have a cross section that is a circle of a triangular pyramid? No. Can you take that triangle pyramid and cut it somewhere to actually get that? Actually, you know what? For the sake of arguments, I'm gonna go get my toys.
Yes.
You're what?
I want to see him top.
That guy.
This is gonna
Is you good?
It's you?
I'm straight.
I don't care your preference.
You got it?
Hey, I didn't ask that.
You did. You said you gonna say yeah. You're right.
Okay. Here's my cone. There's my chop right there, right? Vertical chop.
Yeah.
I got my parabola, right?
Yeah.
Here's my cone. Okay. Cone with my diagonal chop. Okay, I got a.
Oh.
Whoa.
Right, there we go.
No way.
Whoa, no way, man.
I'm on top.
Square base pyramid. Do you think anywhere on here I could actually slice this and get a circle?
No.
Nah. Nah.
No.
Yeah, it's too sharp.
Oh, wait, I actually do have a triangular pyramid here. So, triangular pyramid. Anywhere here, I slice it, get a circle.
No, of course not.
Rectangular prism.
Nah.
Anywhere on here I can slice it to get a circle.
Nah.
Cube.
Nah.
And the rest of them?
The rest of them, yeah.
How about that cone?
Yes.
Yes.
Yes, ma'am.
Yep. Look, I already sliced the top off, and what do I get? Right there.
That's a perfect circle.
There we go.
Yes.
Cylinder.
Yeah.
Taller.
Yeah.
This used to be taller, but I sliced off the top, so
Yeah.
it gave me a circle there, right?
Would've gave you a circle.
And look, I took my sphere,
Yes.
take my sphere right there, and watch. I'm gonna cut it right now. Watch. I'm gonna break your tooth. There we go. All right. So look at that. We get a nice circle right there. Select all figures where it's possible to have all cross section in a particular direction have the same area. This is actually kind of weird
Yeah. No kidding.
because let's take a look at a couple of these. If I slice this, I get a triangle, right?
Yeah.
And when I slice that triangle, can I have the same area as my triangular pyramid? Same area. Watch this. Watch. Okay. Two pyramids, right? Okay. Surface area is here. Surface area is here. Is it possible to have the same?
Oh my god. Holy smokes.
How did you do that?
Yeah, right?
No.
So I can have those ones be the same. But remember this cone? What is the shape if I cut it directly down the center all the way down? That would be a triangle. Would that be the same thing here too?
Yeah.
It would. So all of these right here should all have, those should be the same shape. So we'd say yes, right?
Really?
Those ones right there, I would say yes, right? Okay, so now let's take a look at the next one. A cube. Here's my cube. Okay, I'm gonna skip cone. Okay, actually I'm not gonna skip cone. So let's say that cube right there, because I have to get one that matches this. Where's my other? Sorry. Oh, here it is. And this one. There we go. Okay. So this is here's my cube. All 4 sides are the same, right? Or all 6 sides. Okay, so man. Okay, I don't know. Okay, but now this one, the cone, I was able to get with this one here too, right? So triangular. Rectangular prism. Oh crap! I messed up. It's gotta be this one, not that one. Rectangular prism and cylinder. I want to show you these ones. No, because I made a mistake on this one right here. Sorry. I made a mistake because I did these 3 first and I wasn't paying attention. I was like, wait a minute. Circled the wrong thing. Rectangular prism is here.
You say you're gonna show us the colors?
Rectangular prism, and here's a cylinder. If I slice this cylinder straight down here, what is the cross section going to be? It's a rectangle, isn't it? Look at the shape in the 2-dimensional here, please. This is a rectangle, and this is. Do they look like they're the same shape here? You already know that they're 3-dimensional, right? But if you looked at this right now, you're like, hey, those are the same. You would say rectangle and rectangle, right? So is it possible to get the same area on these 2 rectangles? Yes, that's the point I was trying to make. So this one, and where was the other one? My cylinder.
Then why'd you cross out C for?
It's C and F.
It's they go together. All of them are right in some way. Because cylinder and sphere. Okay, here's my sphere. Here's my cylinder. Okay? Let's look. If I cut this right there, what if I cut this in half right here? They go on together, right? So it's possible to have a cross section with the same areas here, right? All these, in a way, are good because cone and cylinder are yes.
So C?
A cylinder and a sphere, yes. So there's so many ones that actually fit here because I could also do this here, right?
Okay, so I'm like confused because I only.
This is one of those trick questions. All are the right. All of them could be right. Because let's look at my, look at this. Watch this. Because it was part of that one right there. Okay, so I have my cube and my rectangular square base pyramid, right? Watch this. They both have the same surface area right there, don't they? So it's possible for these two. So in this case, all of them are going to be correct, but you just have to know which ones they go with. That's why I wanted to take out my, my blocks.
You just circle them all?
You're not going to have this question, but you're going to have a question about cross sections. You're going to have this type of question with cross sections. Like what shape is a cross section, have the same cross section here. So these two have the same cross section, right? So these two have the same cross section. Do these two have the same cross section?
Yeah.
Okay, so now let's go back to, where's the other one? So if I did this, I'm gonna say, hey, if I look at this on a flat and I just look at it as triangles, would they have same cross sections? Yeah. So you guys have to think about it of what has the same amount. Which ones are gonna look the same when I cut it?
That's not on the test, is it?
No, you're just gonna have the concept of it, of what the cross sections are gonna be the same. Alright, what is the shape of cross section formed by intersecting a cube with the plane that passes through the opposite edges of the cube. So, opposite edges of a cube. Now, I want you guys, here's my three-dimensional cube, right? So, I'm going to slice it, and you guys are going to watch me. I'm going to slice it right here. I'm going to slice it right here, okay? From here to here. But this is what you're going to look like in a two-dimensional shape. So, because people are playing on their phone, and they just don't care. So, if you think about it, this right here, if I look all the way across, that's going to give me a what? No. Look straight. Look at it flat.
Square.
That would be a square or a rectangle, right?
Yeah.
So when I cut crossway through those, right? So I cut this way. I cut this way here, so it came up like this. And so, yes, it looks kind of like an optical illusion because the camera only shows that it's flat. Right? So I'm going to get a rectangle there. Okay, what shape of the cross section for my intersecting cube with the plane that passes through here? So what was that? That was a rectangle, right? Sebastian, go put your phone over there, please. Yes, it's side to side, all the way across, right? Okay, through opposite edges. So it's referring to these two right here.
Yes.
Okay, so are you looking at the thing? Now think about it in a two-dimensional shape though. But so you have to disregard, so let's say this right here. So all the way from here to here is just going to be a rectangle, right? So here's one side, another, down, and here. I've already asked you.
I'm getting picked up.
Not soon enough.
Yeah.
Yes, he is.
Okay. Does that make sense now?
Yeah.
Okay, good. I'm trying to get the answers for the test, so please. Now, this one right here, what page was this in my notes?
Page 27.
Okay, this said sketch the volume, rotated it, right? What is it?
I don't know.
22? So it's going to be just like this. So what I'm going to do is I'm going to rotate this way. And rotate this way. So from here,
It looked like
some type of vase, right?
yeah.
So, because I'm rotating it around like this, so it's going to be some type of vase. So that's what you're going to have to do. And you're going to tell me the type of shape that it's going to be.
Basically the same one.
Yeah, this one's going to be like a shape. This one's a vase, but you're going to have some other basic ones. Okay, so what if I take this right here and I rotate this around? What's it become? No, what shape would this one right here be?
Oh.
Just look at the block. If I rotate the block around, what do I get?
A rectangle.
It's going to be...
A rectangular.
Nope. Because if I'm rotating it, doesn't this spin around?
Oh, a cylinder.
It would be a cylinder. Very good. If I rotate it around fast enough here,
Oh, that's fast. Okay.
yeah, really fast, it's going to turn into this, right? So if I spin it fast enough, it's going to look like a cylinder, right?
Yeah.
Okay. This was one of the homework questions too.
Home.
Draw a two-dimensional figure that could be rotated around. So now, it's basically going to be this. Okay? I only went half, so I went here. And the barrel is kind of round. Okay, it's not straight down, right? Yep, there we go. So it's going to be like that. So that's the piece that is being rotated around.
So would it be?
No, just draw a diagram of what it would be. That's all it is.
Oh yeah, what do you have to do right here?
Okay, rotate this one really, really fast. Think about it. Rotate it really, really fast.
Rotate it for me so I can see.
If you rotate this one, what do you get? That one's going to be a cone, right? Because it's going to be half of this, right? And you just rotate it around and it spins all the way around to make a solid. I would get a cone out of that, right? Okay. This one right here would be my cylinder. It would look like this, right? Now,
And then this is sphere.
and my last one. If I rotate, there we go. There's my sphere.
Triangle.
Dilated by the skill factor.
Okay, what did I tell you about a lesson 4?
I don't know what you told me. I wasn't here Monday. Yeah, put it down.
Do I really need to tell you?
Put it down.
Earbud out. Yes, I can see it from here. No.
What'd you say about number 4? What'd you say about number 4? I didn't hear Monday.
We're not going to have those on there.
Oh, no.
Okay. Listen up, please. A cube is 3 inches long on each side.
Okay.
Oh, that's what I did.
3, 6, 9, 12.
3 by 3 by
6, 9.
3. Okay. What is the surface area? Now, first, what is the area of this front piece? Nope.
You get 9.
Why is it 9?
Because you 3 times 3 times
3 times 3, right? No. Not yet.
21.
It.
You get 9 and then.
There is going to be 3 by 3 is the area here.
You ain't have nice things.
This area of the front equals 9.
Obviously.
Now, that's the surface area of that square. How many, it's not asking for volume yet. How many sides does a cube have?
6. 5. No, yeah. Oh, yeah. Sorry.
It's gonna be 9 on each side, right?
You get 54.
It's gonna be 9 on each side, so 27.
Did you touch the cube?
Well, not 27, but yeah, 54. Yeah.
9 times 6 because each one is 9 and there's 6 sides.
That's B.
That's 8. What is the volume? Volume is what times what times what?
Length times width times height.
So length times width times height gives me what?
21.
What's 3 times 3?
9.
9 times 3?
27. Wait, what? Yeah, never mind. It is 27. Oh, 7 times 3 is 20.
What is the surface area of a cube where each side is half as long?
Half of 54.
Okay, surface area, so let's do a half for each one. What is this? What's half of 3?
1.5.
Yeah.
So it's actually 1.5 times 1.5, right?
Yeah.
You get what?
Because wouldn't you do it like the top one where it'd be like you get the area and then you have to multiply it by 6 and then
Yeah, find the area first.
okay, well if you did the area then you get 2.25.
2.25?
Yeah.
Okay, so it's going to be 2.25 times 6,
And then you get 13.5.
13.5, and that's inches square.
Yeah.
What is a volume where, same thing, 1.5 times 1.5 times 1.5?
33.7.
What is it?
I got 33.7.
No, I don't like that.
Yeah, it is 30.75.
1.5,
No.
1.5 times 1.5.
Yeah, it's 3.375. I put the decimal in.
3.375 inches cubed. Because it's 1.5 times 1.5 times 1.5. Are we okay? Are we okay with that one? Okay. Let's take a look at this next one. Hey, do you guys mind? Seriously?
Sorry.
It takes 2 ounces of paint to completely cover all 6 sides of a rectangular prism box, which holds 15 cups of sugar. Double the dimensions of the box. Approximate how much paint would the new box need. How much sugar would it hold? Okay, 6 sides. Okay, 2 ounces to cover all that. 15 cups of sugar. So it's actually, a cup is not a, it's not like a unit squared type thing. It is it's a type of mass type of doing it. So it's a liquid, it's its own type of volume. It's like the difference in between a kilogram and a pound. There is a conversion, but they're not the same type of units. Okay? So, I'm going to pretend. I like to pretend because I make stuff up all the time. Let's say that my sides rectangular prism is going to be 10. Just because. I like 10. Why do you think I like 10? It's nice, right? And when I do half of it, oh wait, I'm sorry, double the box, it's going to make math a whole lot easier too, right? So 10 by 10 by 10, okay? Right? So this one right here, I need to find the area, which is going to be 10 times 10, which is 100, right? How many sides do I have?
6. I mean, butter.
600, whatever my units squared are, right? And that equals 2 ounce.
Sorry, is that a 4?
Take out the earbuds so I know that you're paying attention again, so I don't have. No, you're not. You're just changing the music.
Yeah, but I'm still paying
No,
attention.
you're not.
But I am.
Take them out. All the way out. Leave it out. Okay. Now we're going to double the dimensions of the box now. Okay. Let's double the dimensions of the box.
Alright.
So now it's going to be 20, 20, 20, right?
You said 20, 20, 20.
Yeah, because each one is doubled, right? 20 by 20 is 20 times 20. Try again.
400?
Yep, 400. 400. And how many is there? 6. So 400 times 6.
2,400.
And that's going to be my units. Or unit squared, right? Okay, so now, if 600 takes 2 ounces, 2,400 is going to be how many?
6 ounces.
200, so I could even set up as a ratio. Okay, but I know you guys can figure this one out. So it's units squared, so it's going to be 600 over 2,400, right? Is equal to 2 over, I don't know yet. Yeah, because you're trying to figure out how much paint covers this, right? Yep. So it's going to be 600x equals 4,800.
4.
So it should be,
Yeah, 8.
is it 8? Yep, should be 8. So that is 8 8 ounces. So now I just found the 8 ounces, and that went with this one, right?
Yeah.
So double the dimensions of the box. Approximately how much paint will it take? Will the new box need? Okay. How much sugar would it hold? So now let's go with volume. I'm doing the same problem, but now I'm going to be dealing with volume. What is the volume of this? 10 times 10 times 10. Volume is 1,000 units cubed, right? And that, so my 1,000 units cubed is equal to how much sugar?
15 cups.
15 cups. It's right here. All right, so now my new box. My new box. So what is the volume of the new box? 20 times 20 times 20. 8,000.
What?
20 times 20 times 20. And I could do the ratio again, right? So I want to know how much this one's going to fit. So if it's going to be 1,000 over 8,000 is equal to 15 over, I don't know yet.
Why not?
Because you have to do the math on it, and I'm waiting for you. Do the math.
Let's probably use your calculator.
No.
I got 120.
120?
Yup, 120.
120. And what is that going to, what are my units on that one?
Units cube.
What is it?
Sugar.
Cups. It's going to be 120 cups.
So basically,
No, 120. Because it's going to be 15 times 8,000.
It's gonna be D.
There's not a D. It's not a multiplication. It's we're doing problem 2.
Oh.
Yeah, you weren't really paying attention right there, so I just left you behind. Yep, it's going to be 120 cups. So, pay close attention. So, there was all this work right here is for this problem right here. Okay, now for this one right here, cross out number 3. So what are we going to do tomorrow?
Review.
We're going to finish the rest of this, okay? Like, share, and subscribe.
And then there's